Hey guys, it's me, Miss Miller, and I'm back again to teach you how to multiply polynomials. More specifically, we're going to talk about binomials times trinomials, which might sound a little intimidating, but as always, we are here to help, so let's dive in. All right, let's remember our distributive property. So here is our first example. If we take a look, I have 5x, and we are going to multiply that to each term. So I will do 5x times x squared. That's a 1x squared, which gives me 5x to the third power. We want to be careful that we always add our exponents. When you have a singular x, it's like x to the first. And then we distribute again, 5 times a negative 3x. It's important to identify this is a negative 3x. So we have negative 15. And now we'll have x squared because x to the first plus x to the first is going to give us x squared. And lastly, we'll do 5x times positive 6. So we get a positive, not just 30, but we also include the x. For this next problem, we aren't multiplying a variable times the same expression. Notice it's the same expression, but rather now a number. So we have negative 2 times 1x squared. So I get negative 2x squared. I do this again. Negative 2 times negative 3 is going to give us a positive, because a negative times a negative. Remember, you always take the sign that's in front. So we have negative 2 times negative 3 is positive 6, and we're going to carry the x that's here. And then negative 2 times 6 gives us negative 12. So this is just a reminder of our distributive property, where we have one term like 5x and another term like negative 2x being multiplied to a trinomial. We call this a trinomial because there are 3 terms inside the parentheses. And this is an introduction to a binomial times the trinomial. So if we take a look, what I've done is that 5x minus 2 is going to be multiplied to x squared minus 3x plus 6. Now, if you need to, you can cover up this 2, not think of it, and we're just going to multiply 5x like we did before to each term. So I'm going to do that now. 5x times 1x squared, and this is 5x to the first. So I get 5x to the third. 5x times negative 3x is going to give us negative 15x squared. 5x times 6 gives us a positive 30x. It's important to keep my terms straight. Now, we've exhausted or used up the 5x when we're multiplying. Now I'm going to take a look at this negative 2. So I have negative 2 being multiplied to 1x squared. So I get negative 2x squared. This is all one expression, and we'll simplify in a minute. But negative 2 times positive 1x squared gives me negative 2x squared. Negative 2 times, again, negative 3x is a positive 6x. Negative 2 times a positive 6 gives us negative 12. It's really important to keep track of our signs. Now, when I look at this entire expression, I'm going to want to combine like terms. Remember, like terms have the same variable and the same exponent. So 5x to the third, is there anything else to the third power in this expression? Not that I see. So I am just going to copy back down my 5x to the third. There's nothing that has a like term. But now when I look, negative 15x squared has a like term with negative 2x squared. Negative 15x minus 2 these are both squared, so they're like terms. It gives me negative 17x squared. So I get a negative 17x squared. Now, I'm going to look again and see if I see any other like terms. Positive 30x and positive 6x together. So we have 30x plus 6x. Now you don't have to do this side work, but I'm just showing you where I'm getting my numbers from. 30 plus 6 is 36x. And negative 12, there's no other constants in this problem, so I'm just going to bring it back down, negative 12. And this right here is my final answer. And conveniently, this is in standard form. Remember that standard form goes from highest degree, so power of 3, power of 2, power of 1, and then no variable. That is your final answer. Ready to do more? I know I am. All right, next example looks very similar, but what we're going to do is make sure that any term that doesn't already have a coefficient has one. So I have 1x plus 4, 3x squared, and remember x is to the first power, this is to the first power, and now we can go ahead and multiply. 1x to the first times 3x squared. That is going to give us 3, because 1 times 3 is 3, x to the third power. I do it again, and I get 1 times negative 4x gives me negative 4x squared, because again, we're going to add these exponents. So 1 plus 1 is 2. All right, go to our last term. 1x times negative 1x gives us negative 1x. Remember, you are multiplying, not adding. Now the next term is in my binomial is positive 4. So I'm going to do positive 4 times positive 3x squared gives me a positive 12x squared. Again, there's no x here to combine, so it's just 4 times 3 is 12, and we carry the x squared back down. 4 times negative 4x is negative 16, and we get just x. No x squared because there isn't an x to multiply. And last, 4 times negative 1 is negative 4. Our last step, again, is to combine like terms. So there is nothing that has x to the third in this problem, so that is just going to come right back down. So we have 3x to the third. I'm going to move on to my next term, and I have negative 4x squared plus 12x squared. So negative 4x squared plus 12x squared. A negative plus a positive. Since my positive number is greater, 12 minus 4, that's what you can almost think of this as, and we get 8x squared. It's a positive 8x. Please use a calculator if you're struggling with the positives and negative numbers. So we get a positive 8x squared. All right, does anyone else see a like term here? I see a negative 16x and a negative 1x. So negative 1x minus 16x. We're subtracting negative 16 from negative 1, which gives us negative 17x. When you're adding like terms or subtracting like terms, your exponent stays the same with your variable. So I get negative 17x. And my last term has no like terms, so that just stays there. And again, this will be my final answer. All right, one more to end today's lesson. So this is set up a little differently. You may or may not come across this, but I just wanted to show you it's the same steps we've been doing, where first we distribute. So here's my first term. This is a positive 2, and I multiply it to my first term of negative 9x squared. So I end up with negative 18x squared. 2 does not have a variable, so this is just x squared. 2 times 1x. I'll put that little 1 there if that helps you. So I get a positive 2x. And my last term, 2 times 5, I get a positive 10. The next term in the binomial is a negative 3x squared. It's really important that that's what we're distributing. So negative 3x squared times negative 9. A negative times a negative gives us a positive. And we're going to get a positive 27x to the 4th. Because x squared times x squared is x to the 4th. There's 4 x's. We'll do this again. That wasn't a nice arrow, but we're going with it. Negative 3 times positive 1 is negative 3. And I have 2 x's here, and I have 1 x here. So I get x to the 3rd. And last but not least, I have negative 3x squared times positive 5x. So I get negative 15x squared. Now again, here comes the time for us to combine like terms. When we go ahead and combine like terms, I'm also going to look for the highest degree. The only like terms I see are negative 18x squared and negative 15x squared. Remember to always take the sign in front of the number. And when you combine that, you get negative 33x. So if you want, you could write it as negative 33. Oops, I said 33, but not writing 33. 33x squared. And then everything else is just going to come on down. So I have plus 2x plus 10 plus 27 x to the 4th minus 3x to the 3rd. Now, if I want to write this in standard form, which is what our goal is eventually, I want to look for the highest power. So 27x to the 4th is the highest power. So that's going to come first. Then negative 3x to the 3rd. Then negative 33x squared. Then plus 2x plus 10. Going from the highest 4, 3, 2, 1, none. And this would be our final answer. This last example is a little more challenging, but just in case you come across one of these, I want you to know how to do it. I hope everyone's doing well, and I miss you all. Have a great day.